Welcome back. We're now at lesson 8D. In a previous class, and actually it was in an email, I asked you to submit your rating of yourself on the amount that you have learned in this class from 1 to 10. Whether you've learned 1 or up to a 10, somewhere in between, I asked you to be honest, and I got answers from some of you, and that's what we're going to use for today. Do you think the amount that the amount you have learned is related to the amount of time you spent exercising or sleeping? And this is a good time for you to stop and to think, because early, actually the first of the semester, you submitted hours that you spend on technology. You submitted hours per week you spend working, and you submitted hours per week that you spend sleeping. And for the rest of this lesson, we're going to talk about how these go together with the amount that you have learned and whether there is a relationship or a correlation with the learning and outside activities. So starting with the objectives, we're going to understand by the end of this lesson that linear and other models can be used to approximately fit our data. Data may suggest a non-linear relationship. We're going to be able to use technology to create a scatter plot and estimate the parameters of the line of best fit. Then we're going to be able to interpret parameters, including slope, y-intercept, and the correlation of the determination of a simple linear regression. Let's review and analyze the data that you submitted for the top 3 categories that affect your learning in this course. And those were the ones that I mentioned earlier. I asked you to send in data on your technology use, your working per week hours, and your sleeping hours per week. The 3 variables that we selected are input. A big deal to put this in your mind and your thoughts, mull around on it let it mull around for a little bit. That technology is the input. The output will be how much you've learned in the class. Because you would think that if you spend a whole lot of time on technology that's non-course related, then your output, how much you've actually learned in the class, would be lower. And vice versa. If you spend less time on outside technology, you would have more time to be learning in the class. That also applies to working. If you're working 40, 50, 60 hours a week, that can take away time from what you're able to learn in the class. You will try to figure out how the input variables have affected the output variable. Question 2 asks us to open a class spreadsheet and select one of the 3 variables that you think have the most significant impact on learning. Highlight that column, highlight our learned column, and we can highlight 2 of them, and it gives us an idea of how. And it asks us to do a couple of things. Generate a scatter plot of your chosen variable like technology or hours working or hours sleeping, and select your ratings of what you feel that you've learned in this class. What do you notice about the scatter plot, and are you noticing any trends? I'm going to keep reading. I'm going to upload the actual Excel that I use in the demonstration in my math lab under document sharing. But for right now, I'm just going to keep reading. You can start and stop, add these words to your glossary or flashcards, whatever you have. But it says, let's determine whether a mathematical model can be used to describe the relationship. So in just a minute, I'm going to go grab 2 sets of variables. I'm going to grab your technology use and the ratings that you sent in on how much you've learned. The process when I grab those is attempting to fit a mathematical model to the data. This process is called regression. I'm going to do it 3 times. I'm going to do it with technology to your rating. I'm going to do it with your work hours to your rating. And then I'm going to do it with your sleep hours to your rating. So we'll be able to look at 3 scatter plots, 3 sets of, let me keep going. It is very rare for a math model to fit the data perfectly. Remember slight differences, like they were talking about the Kelley Blue Book. Many factors have an influence on values of variables. It could be that you misread the directions when you sent in your information. It could be that I've typed the data in incorrectly. We have a very small N. I think only 13 of you out of both of my online classes submitted information by last Wednesday. So we have a very small amount of number, but it's still cool, the results that we're going to get. And that's what's really fun about statistics. You get to look at what you have and then talk about it. In addition, frequently there is unexplained variation among the values of the variables. And we're going to be talking about variation and how do we describe that. The variation is sometimes called statistical noise. That's a cool word too, or a cool set of words. The shape of the scatter plot. So we're going to be looking at the shape. We're going to look at the shape of all three of these. The one with technology, the one with the work, the one with the sleep. Can tell you what kind of assumptions you can make about the model. And this is going to guide what kind of model we're going to use. Is it going to be linear? Is it going to be a parabola? Is it going to be exponential? What's going on here that we want to pick on the data? And I'll show you where that is in Excel. You also saw data that were curved and matched an exponential. And we saw some perfectly linear. We're going to talk to the spreadsheet and we're going to ask it to find us a trend line, and we're going to use the tabs as you see here, and I'll demonstrate those in just a minute. Just a few more comments, and then we're going to get to the Excel file. Question 3, ask us to create a linear trend line as shown above, which was the slide we just looked at. Does the trend line appear to be a good model for our data? We'll ask that question 3 times, once with technology, once with the work, and once with the sleeping. We're going to attempt to use a linear model for our data categories. The spreadsheet regression feature is going to estimate the slope. Okay, big deal. We're going to talk about a slope and what it means. Quick reminder, it's the change in our y over the change in our x. Another reminder, if we are talking about input and output, we're going to be putting technology, work, and sleeping on the input. And the rating is going to be the output. So when we calculate our slope, we're going to notice the number is going to be talking about the change in the rating over the change in, well, it depends. Are we going to be talking about technology, the work, or the sleeping? We're also going to talk about the intercept and where it hits the y-axis, and it's the rating, where the rating's starting. Are we going to hit that rating and go up? Are we going to hit that rating and go down? We can make some guesses, but we want to look at the data. The line is called the line of best fit, and the spreadsheet's going to provide some more information about how well this line is going to fit the data. In fact, it's going to look like this. So finally, we're now at question 4, and it tells us in the spreadsheet we're going to use regression to calculate the parameters of the line of best fit. And if you have not paused this video yet to write down a whole bunch of vocabulary, a whole bunch of ideas on flashcards or a Google Doc, this is going to be a great time to hit pause, write down all of these words you've been seeing, different things of what you think it's going to be, and then once we do the graphs, you're going to be able to write down examples. All of this is going to be called running a regression. For each one that we run, we're going to run 3. We're going to write the slope and a practical interpretation. In other words, we're going to remember it's the change in y, which is the change in the rating, over the change in, well, it's going to depend, either the technology use, the working, the sleeping. And here's where we're going to put the slope and interpretation, once for technology, once for work, and once for sleeping. Before you start this part, go into my math lab under document sharing and grab this document. It's the Fall 2018 Online Lesson 8D. And what you'll notice are these pieces. You'll see that I have learning ratings, learning rating, learning rating, learning rating. Those are all 3 columns of the same information. Your identities are not in this data, but somebody rated that they feel like they've learned about a 7 in this class, and they reported they spend about 8 hours a week on technology, about 40 hours a week working, and about 60 hours a week sleeping. So what I have done, as the directions, all of those directions we just went through, I highlighted these two columns. The one I highlighted first, the hours of technology, will be the input variable. The learning rating is the output variable. And then I've gone to insert, scatter plot, and what you see here is what it created. So they've asked us several things while we were reading through all of that information. And when you look at this, it looks like, oh, and I can't draw on this one. It looks like it is trying to be a linear, a line. It maybe has a little bit of a curve going up and then back down. That's very possible. I'm going to go ahead and click over here and get the plus. And they'd asked us to go find a trend line. And when I go look for the trend line, it comes up linear. I can request something different, linear, exponential. I'm going to go ahead and go with linear. And more options. I'm going to scroll down and ask it to display the equation on the chart. And I'll hold off on this next one for just a second. So I need you to go to get these numbers, and I need to write them down also. I need you to get the numbers that for the hours of technology as compared to the rating. What you need to write down is the slope is, let's write 0.03, 300ths. And I need you to write the y-intercept is 6.35. Just 6 if you want, but I think 6.35, 6 and 3500ths will be more accurate. And while you're there, we're going to go ahead and display the r squared. And I need you to also write down that r squared is 0.0553. Write those pieces of data down. So now I've grabbed another two set of columns. I've grabbed column D and column E, and that's going to compare hours working to the learning rate that you submitted. And this thing just pretty much looks like a mess. It is all over the place. If it was a line, maybe it's going down to the right a little bit, but there is no organization. It just looks pretty bad. So to be able to say the number of hours you work correlates with your learning, that's not showing up in our class. I'm going to go ahead and hit plus again, ask it to do trend line, and it gives us a linear. So I'm going to ask it to, on more options, to go ahead and display the equation and the r squared. I need you to write these pieces of information down also. For the hours working, you need to write that the m is 0.0032. You need to write that the y-intercept is 6.94, and the r squared is 0.0024. Finally, I've highlighted the last two columns to compare sleeping with learning. And notice that this scatter plot actually is looking organized, like a line going up to the right. So let's get its data. Let's get the trend line. More options. And on more options, again, I want to display the equation and display r squared. And I need you to also write this information down for hours sleeping. Go ahead and write down the slope is 0.06, 600ths. Write down that the y-intercept is 4.5, 4 5/10, and then write down that the r squared is 0.4965. Write those down, and I'll see you back at question number 5. So actually, I want to meet back at question 4. And on question 4, I would like to talk about the slope, and it's not listening to me. Hang on. Here we go. I would like to talk about the slope and the interpretation of each slope. So let's start with hours of technology use. The slope you wrote down was this, 0.03. Remember, a slope really has two parts. And remember, on our graph, the rating was what we had on our y, and then the technology hours, those are what we had on the x. So with this being the change in y over the change in x, I need to see the words that's something along the lines of this. And it says something like this. Our rating of what we've learned in this class will go up 0.03 of a point for every 1 hour of technology we use. Another way to say that is, for every hour of technology we use, our rating of how much we've learned in this class will go up 0.03 of a point. This is a good time to hit pause and do the same thing for our working hours and our sleeping hours. Hit pause, write these other two down, and then come back. Your working hours, we got a slope of, remember this is also actually in two parts. So this one is saying, remember change in y is our rating, and in this case it's over our working hours, and this is the one that was all over the place. And what this says is our rating will go up 0.03 of a point for every 1 hour we work, or for every 1 hour we work, our rating will go up 0.03 of a point. And up being, it was a plus on our graph and the equation it generated. And then finally, the slope for sleeping. The slope of sleeping was this, change in y is in the numerator, over change in x. So our rating will go up 0.06 of a point for every 1 hour of sleep or additional hour of sleep that we get. It's interesting that this is the working one, is probably the least impactful. And then technology, which I would predict that it would have a negative correlation, like the more hours of technology, the worse your rating. And then sleep, it makes sense. If you're getting more rest, your rating, your learning should go up. It's really fun to notice these are the numbers of our classes. There's one more concept to learn, to analyze, to look at in this lesson. The spreadsheet's going to also tell you the variable values of two statistics that tell you how well, so break out that vocabulary list again, how well the line fits the data. One is noted as the correlation coefficient, which is noted by an R. The other has a similar word in that it's the coefficient of determination, and it's denoted by R squared, which is the square of the R, the correlation coefficient. We're going to examine these in future lessons, but for now we're just going to focus on the coefficient of determination, R squared, which tells you this, make sure you're writing, what percent of the variation in the output variable is due to the input variable. So hang on, output. In this case, our output was the rating. Our input was either technology, work, or sleeping. So the question we just looked at on number 4 of how to take a slope and interpret it, I can almost guarantee we'll see a question like that on the test number 2. Here's another one that I can almost guarantee you're going to see on test number 2. So it says write the coefficient of determination, the R squared, as a percentage, and then interpret that value by filling in the blanks of the following sentence. So you need to have this language in your memory. Variable 1 was our technology. And when we looked at the R squared on the technology, it was this number. It is a decimal and written as a percent. It's about 5.5 or maybe 6 if you want to go there. 6% of the variation from the predicted value for learned is due to the change in other words, in our learning rating. I got to make it make sense in my brain. So 6% of this variation, the difference, what's going on, is in this predicted value of your rating is due to the changes in the technology variable. 6%. Not a whole lot, but there is some of what's going on that's attributable to technology use. So now is a good time to hit pause and for you to answer question number 6 and answer question number 7, and then come back and we can answer them or work on them together. Our second variable included hours of work. And so when you look at your R squared that we saw on the Excel spreadsheet or the graph, we had this number. It says write it as a percent. So wow, not even 1% and very close to no percent of the variation from predicting what our rating will be is due to the changes in our work variable. This is the one that the scatter plot was just kind of weird. It was all over the place. So not much of our classes work schedule and our amount of learning in this class are connected. Less than 1% is accountable or used to predict the variation of our rating based on the changes in our work hours. Let's do it one more time. Variable 3. That was our sleep. So the R squared on sleep was nice. So about 50% of the variation in our rating of how much we've learned in this class is due to the changes in our sleep hours. That's cool. 50% is a lot. Less than 1% is not. So what kind of conclusions can you draw from your analysis of the 3 categories variables and their effects on your learning and performance in this course? And so you write something down, what you think is interesting. This is just really cool to me, how we only had 13 students report, and you reported information back at the first of the semester and then last week, and then it still looks like we have something, that there is something of interest. And so something that I would write is that what you all reported on work didn't really have an impact on your rating, whether you worked a lot of hours or a few hours. And then the first part, the technology, that came up with about 6% of the variation is attributable to technology. That's not really a whole lot either. But what's really neat is that as a scattered out set of 2 online courses, together your data show that 50% of the variation from your rating of how much you're learning in this class can be due to the changes in sleep. The more sleep, the better your rating. You write some conclusions, and then I'll talk to you about question number 8. In this week's weekly email, I'll be asking again for another rating, and I have high hopes for better numbers than 13 of all of you students in my 2 online courses. So when I ask for those, I've asked for you to send them to my email and just send the number. Some of you scanned what you see in front of you, and that's okay too. I'm filling out the form for you at my home, and so you just send the number when you read that I'm asking for it. And this is asking just a little bit different than how much do you think you've learned of all of the content this semester. So this concludes our lesson 8D. Look at your syllabus and see if you have more lessons to do to be prepared to do this week's homework. Bye-bye.